Hey guys, welcome back to my channel, and in today's video we are going to solve one more interesting question. That is question number 1971. Find if path exists in graph. This question number sounds like an Indian horror film, but this question is not a horror question. This is a very easy and really interesting question. So if you are a beginner, then this is a really nice question to start with. And let's see what this question is all about. And before that, let's see in what all companies this has been asked. So we can see Google and Microsoft has asked this question in last 6 months or 1 year. So now let's see what this question is all about. So this is a bidirectional graph. So in the question it is given that there is a bidirectional graph with n vertices where each vertex is labeled from 0 to n minus 1. The edges in the graph are represented as a 2D integer array edges where each edge I is equivalent to a list of two values, that is u and v, which denotes that there is a bidirectional edge between u and v. And each vertex pair is connected at most one edge and no vertex has any edge to itself. So we have to determine if there is a valid path present between the source and the destination vertex. So source, vertex, n and the edge array is provided to us. There are 4 things that is being provided to us in this question, and we just need to check whether there is a valid path or not. So if there is a path existing from source to destination, then we will be returning true as an answer, and if not, then we will be returning false. So in this example we can see that this is our edge array where the number of nodes is equivalent to 3, source is 0 and destination is 2. So when we have plotted this graph, we can clearly see that from 0 to 2 there is an edge, so there is a path, and that's why we returned true as an answer. So we don't have to return the number of paths or the shortest path, but we just need to check whether there is a path or not. So that in that sense this question is pretty easy, and let's understand with one more example. So in this example we can see that there are 6 nodes and these are the bidirectional edge connections given in this array, and source is 0 and destination is 5. And we can see that in this diagram these 2 nodes are not connected to any of this part of node where the destination is present. So as there is no path, and we can clearly see that after reaching 1 or 2 node we won't be able to proceed and ever reach our destination. That's why we are returning false, because there is no path with which we can traverse from source to destination. So these were the examples. Let's understand this question even better and come up with a solution. So as in the question itself it is given that we are working with the bidirectional graph, correct? So we know that we are working on graph, and when we are working with graph we know that there are 2 types of traversal, that is BFS and DFS, that we can traverse this whole graph and come up with a solution or just check whether a path is existing or not. So in this we know that the solution was from 0 to 1, and also we can from 0 to 2, and also the path is from 0 to 1 and then from 1 to 2. So there were 2 paths, so we don't need to be concerned about that part where we need to check the number of paths, but we just need to check whether there is a path or not. In the same manner, here there is no connectivity, that's why we returned false as an answer for this example. So if I am saying that we can solve this question using 2 traversals, because at the end we just need to traverse this graph and we need to check whether from starting source node we are ever reaching the destination node or not. Once we reach the destination node, we will simply return true, because somehow we are able to reach the destination, so there is a valid path existing. So we just need to traverse this whole graph and we just need to keep on checking whether whether the node at which we are present is a destination node or not. If it is, then we will return true, and if not, then at the end we will return false. So we just need to perform a traversal. So for this question, we are going to solve this question using BFS. So let's see how we can solve this question. So firstly, as in the question, it is given that the data is given to us in a form of 2D array, right? 2D array which is named as edges. And edges is consisting of all the vertices and edges connections. So firstly, we need to transform this and we need to create a list or adjacency array where we can check if we are at 0 node, what all are the neighboring nodes. So for that, what we can do is we can create a dictionary. So suppose this is my dictionary where I am saying node 0 is connected to 1 and 2. And in this manner, we will firstly map the whole data or transform the whole data so that we can easily check what all nodes are connected. So in this manner, we can create an adjacency list so that it will be easier for us to check and move forward. So this is the first step that we will be doing. After creating adjacency list, what we are saying, now let's start traversing, and we will start from this source. So as soon as we reach this place, firstly we need to check whether this is a destination node or not. So destination node is 2. So we are saying no, this is not a destination node. So okay, fine, this is not a destination node. So now let's check the adjacent nodes of this node. So adjacent nodes are 1 and 2. So before moving to 1 and 2, what I need to do, I need to firstly mark this node as visited. Why I have to do that? Because we are working with a bidirectional graph. So we can't only move from 0 to 1, but we can also move from 1 to 0. So if we have already visited 0 and we have already visited the adjacent nodes of 0, then is there a need to again visit the same node? No, right? So just to cut off that repetitive work, what we are going to do, we are going to create a visited array as well. And we are going to keep a check of all the nodes that we have already visited. So in this case, we have visited 0, and now we are moving towards the adjacent nodes of 0. So now we will come to this, where this is 1. So we are again going to check whether this is a destination node or not. So no. So now what we need to do, we need to firstly mark this node as visited and need to check its adjacent node. So we can see its adjacent node is 2, which is same as 0, correct? So we are going to come up to this place. Now again we are going to check the same thing. Is this our destination node? So yes, this is. So we are simply going to return true. At this point, we are not going to do anything. We are simply going to return true. So this is how we need to solve this question. So firstly, we need to check whether the node at which we are present is a destination node or not. If not, then we are going to simply check the adjacent nodes, and we are again going to call the DFS on that node where we are doing the same thing. That is, firstly we are again going to check whether this is a destination node or not. No, then we are going to call DFS on its adjacent node. And this is how we are going to solve this whole question. So let's quickly code this whole solution. Before that, let me tell you the space and time complexity of this whole approach. So the time complexity of this whole approach is going to be big O of m plus n, where n is the number of nodes and m is the number of edges. So like here we are creating adjacency list, right? So for that it will take around big O of m time. After that we are visiting all the nodes and checking that this is a destination node or not. So for that we will take big O of n time. So in this manner we are going to take big O of m plus n time. And space complexity is also going to be same. Why? Because firstly we are creating this adjacency list which will take around big O of M space. After that, we are creating this visited array to keep track of all the visited nodes, and after these two steps we are also using DFS to solve this question. So DFS calls will also create a recursive call stack which will take up to big O of n space. So in total the space complexity will also be big O of m plus n. I know right now it might be a bit confusing to understand, but once we will write the code, it will become more clearer to all of you. So let's quickly code this whole solution. So firstly, let's create our adjacency list. So for that, what we can do is we can create a graph data structure which will be collections.default dictionary. And what we are going to do, we are going to run a loop for A and B in edges, and then we are saying graph of A will be appended with B and graph of B will also be appended with A. Why we are doing these two steps? Because we are working with bidirectional graphs. So it is not only like we can move from A to B, but we can also move from B to A. That's why we are creating this kind of structure. After this, what we need to do, we need to create a visited array so that we can keep track of all the visited nodes, and its length is going to be equivalent to n. And after this, we are going to define our DFS function in which we are going to pass node. So inside this function, we are firstly going to check if the node is equivalent to destination, right? So if the node is equivalent to destination, then return true. Else, what we are saying is, if this node is not visited, so if not visited, and we will pass this node. So if this is not visited, then firstly mark it as visited. So this will be visited node equals to true. And after this, we are saying for adjacent nodes of this node, adjacent node of this node, perform DFS. And in this as well, we are again going to check the if condition. Why? Because suppose if it returns true, then we are going to return true right here. Else, we are going to return false. And after stepping out of this function, we need to call DFS, right? And in this, what we are going to pass? We are going to pass our source array. So I hope I'm not missing out on something. So let's run and check whether this is working or not, which I think I made some sort of mistake. Okay, I forgot to write return statement here, and that was the reason because of which we were getting error. So now let's see. I guess now it is going to get submitted. Okay, so yeah, just because of that return statement, it was not getting submitted, but now it is submitted. So I hope this video was helpful for you all, and if it was, then don't forget to like, share and subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms, and thanks for watching.